Hello, everyone. Thanks so much for joining us today as we talk about bridging between CAD and GIS, 8 paths to success. We've got 8 ways to build that bridge today, and we're very excited to show them to you. My name is Dale Lutz. I'm one of the co-founders of Safe Software, and I'm joined today by
Javita Chan. I'm a technical support specialist on the desktop side.
And together, Jovita and I are really looking forward to showing you a number of useful ways to make your data exchange go ever smoother between CAD and GIS. And so thanks so much for joining us.
Throughout the webinar, we have our dedicated team on Q&A, so please feel free to type your questions in and we'll do our best to answer them.
So our agenda for today is that we're going to start off looking at migrating CAD drawings to GIS. And there's a number of challenges there to dig into, and we'll be looking at some real world solutions, as well as Jovita finishing us up that section by looking at a demo of digital plan submissions. Then we're going to go the other direction and show how we can share data from GIS back to CAD. And again, there are some solutions to challenges that will be fun to go over and useful for you to be aware of. And lastly, Jovita will show us how she can create a portal for requesting CAD data from GIS. And then, of course, we'll finish with some questions and answers. By way of introduction, we are Safe Software, and our mission is to help you maximize the value of data. We've been around for 28 or more years now, helping people move from CAD to GIS, to raster, to LiDAR, to database, to pretty much you name it. But our bread and butter has always been CAD to GIS and GIS to CAD. We make this product called FME, which today is an integration platform. It allows you to connect to data, to transform it, and to automate that transformation. And today we'll be showing you all aspects of that in our demonstrations. The integration platform consists of FME Desktop, where you build and run data workflows, either ad hoc or else you're setting them up to be run in batch. You can take those workflows and move them up to FME Server, where they can run in an automated fashion, whether your hands are on or off, whether you're sleeping, whether you're out having lunch, your data transformations can take place. And Jovita is going to show us some of that later. FME Cloud is a hosted version of FME Server where you pay by the hour. And we do have a couple of mobile apps that let you control these data transformations and also display your results in augmented reality. Back to the topic at hand about CAD and GIS. There are two fundamentally different perspectives that these two worlds have, and that's why we've chosen the theme of building bridges, because they can be bridged, but it requires some understanding and finesse. CAD users tend to have a drawing perspective. They care about layers and levels, styles and symbology, labels and dimensions, but they're not typically is interested in some of the same things that the GIS folks would care about. GIS people tend to care about data structure, data models, relational tables and domains, coordinate systems. That's a big one. A lot of CAD drawings don't know their coordinate system, and so they end up out in the middle of the Pacific or Atlantic Ocean. Connectivity is also very important in GIS, whether it's to create network models or to create areas from lines. Those are both common operations that happen when we are moving from CAD to GIS, and we're pleased to say we have tools that help with all of that. And of course, attributes are so key for GIS users, and often the CAD users don't have those explicitly there, and they have to be derived from the positions. And we'll be looking at all this sort of stuff today as we dig into our scenarios. So the first part of our talk is going from CAD to GIS, and we'll start off with the bread and butter original scenario of building areas from line work. And so let's dig into this scenario. The task that we were given, and this actually was the first task that we were actually ever given at SAFE back in '94, is to convert microstation drawings that are forest cover maps and bring them into GIS so we can do analysis. The problem is that the forest cover maps store boundaries as lines and interior points to represent the areas. And those interior points have a node number or some attribution with them. And the GIS we just want areas that have attributes. And so how are we going to win? we're going to use FME, our tool, and its area builder that takes lines and makes polygons, and its point on area overlayer that takes areas and points and puts the attributes onto the areas. We're going to bring all that together, and we're going to create ourselves a GIS-ready data set that we could run over and over again if we wanted to over all of the maps in our area. So this is the specification. This is an old MicroStation specification, and I see level 9, type 3, type 4, color 2. These are the specs that are defining the lines that we're going to build our areas from. Level 10 is where the labels are that we want to join. These are points. And so this is the spec we've been given. And our input looks like this inside of MicroStation. And so this is what we have to begin with. You see things like a line string on level 9 and so on. And what we want to do is take that and create the solution inside of our FME data transformation. And so here I've gone and I've got it ready. I'm about to add a reader. I've said I want to read from MicroStation design file. I found the so-called FC1, which is a DGN file, and I'm ready to go. And so I'm going to put that down, and here I have my input layers that I've chosen, levels 9 and 10. And I can go inside FME and hit the run button, and I've got something on called feature caching. And this is going to let me see the data that I'm working with as I begin to define my transformation. So I'm going to run the workspace that I've got so far and just take a peek. So there it is, and there's the data that I've got, and it's out there on this map, and I can zoom in and look, and I can see that I've got different colored lines and some points, and I can go out here and select things, and I'm in good shape. I then put down a tester because I want only some of the things on level 10. And here I'm saying I want the things where the element type was 7 and the graphic group was 0. These were things that the CAD technicians used to identify only the polygons that we care about. And so I can see that 862 of the text features passed and 393 didn't. So I got 862 here, and there they are. And I can look at that and see them all nicely there. The next thing I do is I put down an area builder, and that is going to form polygons out of the lines that are coming out of that level 9. And thankfully, we have exactly 862, which matches what we saw when we were filtering our points. And now lastly, I would go ahead and do a point on area overlay, and I'll just show for the folks at home. If I just type on the canvas the name of the transformer I want to use, these blue things are what we call transformers, and we put them down to modify data as we're going. And so by typing the name, then I can choose it. And so here it is, and I've got it ready to go. And now I can go ahead and run this one and overlay the points on the areas. And if I take a look at the, let's say the areas only, there they are. And I can go ahead and zoom in on them and click, and there it is, shows me the attributes of them. And then lastly, I get this ready to go to GIS. So I will go and add a writer, and I would choose, let's say, a shapefile, and I would choose a place to put it. And I've got that ready to go here, and I've defined an output shapefile called forest cover, and I've got a cover ID, which is going to come from the node number, and I've got a map stand, which comes from the name of the original input file. And if I just run this to the end, I can then go and view that resulting shapefile, and I should have my GIS data ready to go. And there it is in all of its glory. Let me just make this a bit bigger so we can see it. Yes. And there it is. And there are our polygons, and we can see them with the various cover IDs and so on. And if I wanted to sort this, I should see that they go from number 1 all the way down to 862. And that concludes our opening demo. So again, the solution was read the DGN file. I exposed or made available the node number, graphic group, and element type. I ran them through the tester to pick out the ones I wanted. I used the area builder to build my lines. I connected or spatially joined the points on the areas, and I output it to a shapefile for use in GIS. And so the recap, again, you know the task, and we saw the solution, the tips. We had to discover the names that FME assigns to the CAD properties to filter and route the data. And we used the feature information window to do that. And I'll actually go back here and just show you that. That's this button here. If I look at the original CAD file and I use the feature information window, get it going, there it is. We can see as I go into here, there we go, all these different properties that come from the CAD file. And these can be used against the specification we had to make sure we have picked out the right things. And we use the tester to filter out what we wanted, and then we use those geometric operations to get the results. So scenario 2, we want to transform CAD to GeoJSON. And the issue here is quite an interesting one. We want a GeoJSON file containing the geometries and text from original CAD files. The DWG file had rooms that were drawn as closed polylines, and there were 2 labels inside there on different layers. And so we wanted to merge that all together and get data where it needed to be used downstream by a mapping application. And I want to just tip the hat to the FME community because that's where this question originally came from. And we do encourage you all to take part in that, join there, ask questions. The sun never sets on the FME community. You can log in and ask questions and join the discussion. You're always welcome, and lots of great stuff is talked about there. So again, here's some simulated input. This is of properties, not rooms, but nonetheless, it's the simulated case. It comes from the Township of Langley. Thank you very much, Township. And what we've done is we've got our parcel boundaries, and in there we've got a couple of labels, the folio and the PID. And so the solution that we've come up with is this. We are going to read, and I'll get this brought up inside of here. So let's make these windows smaller, and I will go back to here. And if I look at number 2, AutoCAD to GeoJSON, I'm going to go ahead and run this, and we can take a look at the data along the way. But we read the folios, we bring along the parcels, we read the PIDs, we go into a text property extractor, which will get the text string, the label, and put it into an attribute here called folio, and another one down here called PID. And so once we have these, now you can see what our data looks like. And then we can again do the overlay. And now we get the result where we have a folio and we have a PID. And let me just zoom to the selected feature. There it is. And now we've got a GIS ready feature, which we can output to GeoJSON. So that's how that works. We've successfully produced a single GeoJSON file. We extracted the CAD properties onto unique attributes, and we actually combined 3 things into one by making use of the text property extractor to bring the properties of a CAD drawing element into attributes like folio and PID. We used the overlayer, and then we used the tester to make sure we weren't having bad data slip through on us.
And it's probably a good time to mention that the FME Transformer Gallery is a really good place to go to find out where all these transformers are found. You don't need to remember all of these transformers. Dale's highlighted a few by now, and we don't know all of them ourselves. So you're able to filter by category using the Transformer Gallery. And the way that transformers are named are through aliases. So it's typically a verb with ER. So if you're looking for a clipping process, you can look for a clipper. Or if you're looking to manage some attributes, an attribute manager. So this is a really great place to look. You can also find it embedded in FME Desktop. So if that's not already open, you can go into Windows, View, Windows, and open up the Transformer Gallery there.
Excellent. Thanks so much, Jovita. A key part of successfully using FME is knowing how to find the transformers that you need to put together like Lego bricks to solve your problem. And that gallery is an excellent resource for sure. Scenario 3 that we had was much like the last one, where we were moving labels to attributes based on containment, but this time we're going to do it onto lines by being close. And so here we have a bunch of labels. They're near lines, and we want to transfer the information from the label to the line. And containment isn't an option. Fortunately, we have our friend the neighbor finder, which is a transformer that uses proximity to pair candidates to lines to give us the attributes we want. And so if we're lucky and we use it right, our label information will be transferred to the lines. So this is the input. Looks like they needed to maybe use some better labeling software when they did this, but nonetheless, the roads are all labeled here. As an aside, a little plug for the map text labeler. That's an add-on for FME. If you're producing CAD files from GIS data, you may want to use the map text labeler. Your labels would not look like this if you did. But if you have this in any case, you now can go and try to match them up. And the way we do it, let's go back out to FME and let's bring up that example. So the name attacher. And so here, what I'm going to do is run to this point here so I can see the text properties. And what's happened at this point is I've taken the labels that are in this data set and I have moved them onto my features or my rows as actual attributes, in this case named road name. And now what I'm going to do is go into the neighbor finder where the roads themselves are going to be the bases. I'll take a look at them. Here are my road lines, and they don't really have any attributes at all. They're completely without, they're just geometry. And I want to match them up. And the neighbor finder has some properties here saying, I said basically, give me the closest one. Give me one neighbor, and I don't have a maximum distance. I don't care. It just give me the closest one, and that's good enough for this case. And so when I look at my results, then I start to see all kinds of useful things. I can see that that is Wright Street, and they can get the text size and other things. But nonetheless, I just wanted the road names to be attached, and Haddon and so on. And so now I could go ahead and route this to GIS. So that's the key thing. If I wanted to, you'll notice here that Wright Street, for example, has several parts to it. And if I wanted to make it as long as possible, and not care that there's junctions here, so that's the key thing, I could use something called a line combiner. Here we go. Let's put down a line combiner, and I'll bring it out and I'll connect it by doing that. I can also just draw lines if I want to. And I'm going to say to the line combiner, I want it to combine on attributes. And so I want it to combine based on road name, which would make me hopefully one long thing based on Wright Street. And if I do that, I have only 47 roads now. And if I go click on Wright Street, sure enough, it's that whole area all the way on that far side of town. So it joins it all the way up. And so again, I've lost my noting, but for some scenarios that might be helpful. So again, this is the workspace we just saw. And what are the tips? Again, we're doing proximity matching, and we use our neighbor finder to do that. You can use the tester to make sure that you have at least one match. And whenever you're doing proximity, you may have to have humans do a final QA, but the tester can match or can tell or deal with the things that might be not enough matches or too many. And then sometimes you might want that line combiner to get rid of what we used to call pseudo nodes to make you long lines. Now we're going to take a brief detour into two battles with what we're calling schema drift within CAD drawings, and probably schema is a bit generous here. Schema drift in general refers to the issue that happens when there's a change in the source or target data definition, and then people have to manually deal with the mess. So someone has said to use schema drift in a sentence, they've added yet another column to my Excel spreadsheet. This schema drift madness has got to stop. That's the kind of thing that could cause heartache. Now, in the case of CAD files, there's a number of ways that this can happen, but one that's very common in kind of Wild West CAD shops is that there's no naming convention for the layer names. And so in this example, we've got roads and streets and roads and road and street lines and you name it. And we want to smarten that up and have a proper specification so we can ultimately go either to CAD or to GIS. And so here we first want to migrate the CAD line work to a new CAD standard, and then we can go and use it afterwards. So this is actually going to go CAD to CAD to clean up the schema mess. So the way we do this is we first go and within our product, we can use an asterisk to say, I want to read all the DWG files in this directory. And what we're going to do to begin with is get a catalog of what all those layer names are. And so by doing that, I can see that there's like every synonym that you can think of for roads has been used here. And so what we want to do then is not have all of those show up on the left-hand side of our workspace. When we create our workspace, we're going to say, instead of giving me an individual feature type or table for every layer in the input, we're going to merge it all into one. And then we just have one thing to deal with. And then what we can do is take that merge thing and use something called a duplicate filter and give us only a spreadsheet of all the current layers, all the unique layers that there were in there. And I'm looking into the future because a human will then go and give us the desired layer mapping. So we're going to use Excel as kind of our stopping point. So here's a CAD to Excel translation. Of course, we're throwing away all the geometry, and all we're getting is a list of all the unique layer names. And here we go, looking at it in Excel. The current layer are all these different things, and I've called them all road on the way out. Then what I do is I create a workspace that again reads that whole same thing, uses what's called a database joiner to go out to Excel and match the layer name to the desired layer, which is going to be roads in our case for these ones. And then we're going to write it out to a new CAD file, and we're going to name the layer after the road. So we do that by going into the properties of the output CAD layer and using an attribute value to supply the layer name instead of a hard-coded name. Because I could have more than just roads. I could have paths and I could have streams and other things in this same CAD file. So if I take a look at this out here, I have my 4A, which is to extract all the names. And I can go ahead and I could run to here, for example, just to see what will happen. Now it's going to go and read a whole bunch of input files while it does this. There we go. So this is our list of unique names. So we got 38 things out of an input, almost a little more than 10,000. And so then I would go and see my Excel file and add that second column, which I've done before. Now this is the workspace that repairs them. So here I added reader. I said AutoCAD is what I would have done, AutoCAD DWG, and then I would have gone to whatever that place was and said star.dwg, and I would have said single merged feature type. That's how I got this in there over here. I go to the database joiner where I've connected it to my Excel file that I have my sanity map that maps the old layer names to the new ones. And then I go and do the fan out. So let's just run to this point here to the database joiner. And again, we will be able to see that they all, I think, should have the desired layer is now road. And it used to be artery, and we'll go down a bit further. Oh, lots of arteries, dragways, and so on, pathways. They all have mapped to road. And then this thing here is where I fanned out. I said, set the output layer name to the desired layer. And that gives me the CAD file that we so are looking forward to. And so that would map them all to one layer. And then we could go and use them inside of CAD or GIS. So again, moving to a naming spec, use a duplicate filter. So we found all the layer names. We did the layer mapping inside of a spreadsheet. We're doing the joining by using the database joiner so that we can have it's a common trick to put the configuration smarts sometimes into an Excel spreadsheet or a database so that we don't have to modify our workspace if things change. And then we use the feature type fan out to route to new layers. This is also an example that we have come across a few times where folks have encoded attributes into the layer names. So the layer name is some combination of things totally unintelligible to a human, but very intelligible to the spec. where you have a chunk that's the 3-letter code for roads, some other stuff, the date, and then the data collection method. And so these attributes are in there, but they're not at all useful for analysis because they're very hard to get at. And so the solution is we're going to split those out to pick out the parts and decode them into useful values. And so this is what the input looks like, fairly, again, not too useful to humans. And here is a lookup that goes from those codes for the method, how it was collected. This is data from Sweden, and the types. So we have these in little lookup tables. And here is our results. And so I'm just going to go quickly and take a peek at that. Okay, so we're just going to go to Workbench, and we will go and look at that example. So here I'm reading all the data again. This is my CAD file. Again, I've chosen a single merged feature type to get all the data into one place. And I'm going to run this, and we'll take a peek at all these different layer names that we've got. And then we're going to go and split. So here it is, and yes, you can see all these layer names that correspond to all the attributes for each of the infrastructure pieces that we're looking at. We're going to go into a splitter, which says split this feature type, the layer name, into 3 characters, 8 characters, and then 2 characters, and put the results in what we call a list. And so now if I run to this spot here, I should see that I have all those codes broken out. There we go. And there they are. And yes, there I can see the name and the SLA, and this looks like a date to me. That's pretty nice. And now I'm going to make 2 hops into different database joins. I'm going to run to this end of the second one where I'll get more human readable results for us. And then we should have a much nicer data set that a GIS person could use. And so yes, you can see here now we've got a type and our original method of collecting the data. And that has been squeezed out of those rather intense layer names. So again, how did we decode these attribute-rich layer names? We split the layer names apart with an attribute splitter. We got at the parts of the list that resulted by exposing the elements. And then we used a database joiner to go out to those spreadsheets that had the decoding values. We could put them also inside of our workspace with an attribute value mapper. And lastly, we're ready to go to GIS. So I think now we'll hand it over to Jovita to show us how to do some digital plan submissions.
All right, in our next scenario, we're looking at a digital plan submission. So we're taking all of those skills from the examples that Dale has put together, and we're rolling it into a more comprehensive example. But first off, we'll take a look at one of our customer stories from the city of Henderson, where they've created a digital plan submission. The city of Henderson partnered with Concertec to simplify and automate CAD to GIS conversion as part of their digital plan submission process for new construction projects. Their biggest challenge was time spent on manual data entry and processing, duplicate work, and the risk of errors. Through one automated workflow, FME delivered a reduction in data integration time by 75%. FME helped the city improve operational efficiencies, save time, and ensured CAD data validation before converting to GIS, while preserving the integrity of the source data. So this is going to be our digital plan submission. We're going to simulate the same thing. I imagine many of you listening in have at one point or another known the pain of receiving CAD files from many different sources and contractors. As CAD files are inherently drawings, they can be a little bit messy. Mistakes or inconsistencies can happen. Things can be drawn a certain way, so they simply look better at the cost of clean topology. So here, we're going to pretend that we're a municipality that approves development plans. We'll create a web service for developers to submit their plans, check them for a certain set of standards, and either upload the file to ArcGIS Online if it passes, or return the sender a report of unmet requirements. This is a screenshot of our source data. So thank you again, Township of Langley. I have gone in and added some additional parcels in AutoCAD, and they're not drawn very well. My CAD teacher would not be proud of this. My parcels are all lines. I do have parcel IDs, and I've added some road and road names, but it's not what you would call clean topology. So this will be the file that I'm submitting as our development plan. And that's what's kind of zoomed in there is our parcels that we'll be looking at. In this example, I've cherry-picked a few examples of typical standards. We're going to look at specific layer naming, so for the layer schema, and we're also going to want to retain text annotations as attributes on the geometry, similar to what Dale had done with road names on the road features. Incoming layers will have to contain specific geometry, so I'm expecting that my roads are coming in as lines, my parcels are coming in as polygons, and that my blocks are coming in as points. So our next stop, we'll head into FME Server to see this CAD validation FME Server app, where developers can upload their plan submissions. If you remember my badly drawn parcels, I expect my first submission to fail, and to receive a report back about why my plan doesn't meet the criteria. From there, we will take a look at the workspace that powers the app, and then resubmit the plan with a cleaned up data set and see what happens. This is FME Server. Right now, I'm just in the Server Apps Managing menu, and I'm going to go into my first one here. Configuring an app is really easy. You just give it a title, add a description, and what actually powers it is a workspace that I can select from my repository. And the service I'll be using is data streaming. I'll get a little bit more into that when we look at the workspace. With that, I'll press OK. And I get this handy URL that, given the correct permissions, I can share that with my colleagues or whoever needs it, and they can access this web page here. I will take my data straight from my file explorer, and I want to use my Langley development plan, which were those parcels you saw in that screenshot. Once that's ready to go, I'll press OK. And what's happening behind here is a workspace is running to check for those standards I had mentioned. So I've gotten an HTML stream of a report back. It seems that my submission has failed due to unmet requirements. On that left column there are those layers that I'm expecting to get, and on the right side are the layers that I actually gave it. In the bottom, I've also got some additional information about certain layers that have the wrong kind of geometry, and I can even include a rejection message about what seems to be wrong. With that, we'll head into FME Desktop to see the actual workspace that runs this. Here we are in FME Desktop for our Validate CAD file for submission. This workspace goes from AutoCAD DWG to ArcGIS Online, assuming that the file passes all of these checks. So we're also writing to HTML to give a report back on whether the plan had failed or whether it had succeeded, and just give you a little bit more information. In this first bookmark here, we're reading in our CAD file, which we can take a quick preview of. Zooming all the way into our parcels. And while I'm here, I'm just going to show you that these are all individual lines here that we'll be cleaning up. We can minimize this. And we'll head into the next bookmark. Once we've read in our data and filtered it by the expected layer names, which was that last one here, the attribute filter, which has populated with my expected layer names. If anything comes out unfiltered, we can create some reporting information to put into our HTML report, just like you saw in our unmet requirements page. If things are fine, things that come through in the correct layers, we're going to check that the correct geometry is coming through, such that we are getting areas from our parcels. Our roads are coming through as lines, text as points, and same with blocks. In this next bookmark, we're checking if anything is coming through unfiltered, which means that the geometry coming through isn't what we expected from that layer. These next two bookmarks are a little bit more reporting, so just to give us a little bit more information about what went wrong. A little bit more reporting here for statistics, and then this is our check for whether everything has come through. This is sort of that critical pass or fail for this workspace or for this plan. And then finally, if it passes, we're going to get this data set ready for GIS, clean it up a little bit, and once again, write a report to let us know that it was successful. And finally, this is our HTML writer. I mentioned writing to ArcGIS Online, and that happens in the feature writer here. From here, getting this into FME Server is really easy. You can hit the Publish button. I'm using FME Cloud, which just looks like FME Server, but on cloud. And I'll hit Continue there. I've got it in my repository, and that's the name I want to use. And I will hit Continue. You can choose to include your connection. And I'll be registering this service as data streaming. I usually like to keep the job submitter as well. So I'm going to cancel out of there because I've already uploaded it to FME Server and I've got an app running it. So I'm going to cancel. From here, we're going to head back into FME Server and we're going to run that same app again, except with a valid submission. And we're going to see what happens there. Once again, grabbing from the File Explorer, I can also choose to hit Upload File here and I'll pull up my File Explorer. I've got a cleaned up data set of valid submissions, and it's still the same parcels, but I used FME on a different workspace to clean it up. Hit OK. And it's a good sign that it's taking a little bit longer. What's happening in the background likely is that it is writing to ArcGIS Online, which takes a little bit longer than when our plan had failed immediately and just streamed back a report. Success. And we even have Zipster. So you can actually personalize this a lot more. You can include a reference number, you can include a link back to the server app if they need to resubmit, but it is a success, and we will go into ArcGIS Online, take a look at what we've written out. Here I am in ArcGIS Online in my folder, and it is the plan submissions that I've written out. I will head into data, and I can see that it was last updated April 13th this year. And just now, perfect. I'm in my roads layer, so I'm just going to scroll all the way down. I had added a couple of Easter eggs in my roads, and I have named some roads after Star Wars. So I've got Janeway Boulevard, Darth Vader Street, just to be able to identify that quickly. And I'll head into visualization to take a look at what that data looks like. In my roads layer, I'm zooming in. Zoomed in a little too much. And I expect to see Janeway Boulevard there, Darth Vader Street, and Akbar Avenue. So those wrote out perfectly. And I'll take a look at my parcels as well. So with my parcels, remember they had first come in as lines. So I'm expecting to see parcel polygons with the IDs on that parcel. So I've got parcel ID 39, 32, and they look to be polygons. With that, we'll head back into our slide deck. So this is once again just a screenshot of ArcGIS Online. So to recap the example, the task was to create a digital submission plan that checks the validity of the DWG file and either passes the file to upload to ArcGIS Online or fails and returns an HTML stream report of why it failed. This provides the submitter with information to fix the file immediately and submit again with no communication wait time, keeping the responsibility back on the submitter to provide a valid submission. At a high level, working from CAD to GIS involves a lot of capturing human-readable information and cleaning up topology so the data set can be used for analysis in the future. Some of the transformers we've noted here from the workspace you saw really highlight that process in creating connectivity, such as the snapper or intersector, and in building areas from lines, such as the area builder, or combining geometry and attributes with proximity, so the point on area overlay for our parcels, or the neighbor finder as Dale had used.
Thanks so much, Jovita, for that excellent demonstration, taking us all the way from CAD files to the web to server apps, ultimately ending up in ArcGIS Online. In part 2 of this webinar, we're going to take a couple quick looks at some of the tricks to be aware of when you're sharing GIS data with CAD users. The challenges when you're going GIS to CAD are definitely different than those when you go the other direction. The key thing is that you need to create visually appealing CAD drawings that are in the language or the specification of your CAD technicians and your CAD audience. Somehow you want to represent the GIS intelligence that's there and use the symbology, the styling, the symbols, the conventions, the layer naming that your consumers want. Fortunately, it's fairly easy to set these up using FME. And so in our sixth scenario, we're going to look at an example where we're applying styling. Thanks to the city of Gävle in Sweden, one of our first customers who first came to us long ago with more or less this situation. So they wanted back then, and today others would want, to produce output conforming to the CAD spec that the engineering department wants out of their GIS. The challenge is that the GIS data doesn't have explicit styling information, but there was a styling spec available. We need to apply it. We can use a styler transformer to prepare the output for CAD, and we also might store some of that styling information in a spreadsheet and apply it during translation, because we're going for happy CAD technicians at the end of the day and a fairly effortless flow of the data between departments and disciplines. That's what it's all about. So here's the input. We've got ourselves some of the features in the city of Gävle. They're inside of GIS, and we want to take them and we want to go out to CAD. And there's the solution. So let me just take a look at this inside of Workbench. So let me grab this example. And so I'm reading this shapefile. Let's just get a peek as to what it is. These are a bunch of points. You have to know Swedish to know what they actually represent. They might be trees, I think. I don't know. I should have looked that up. But nonetheless, you can see these points are there. And we're going to go into a DWG styler, and we're going to use a template file, which came from our friends at the city. And then we're going to apply a block name with a scaling factor. These could come from attributes if we had them. In this case, we don't. And we're going to place blocks at all these point locations. And so all we're doing is preparing the data by adding different attributes to it. So if I look at the results here, you don't really see anything much added. But if I look at the feature information window for this, I would start to notice special AutoCAD underscore attributes. And these come from our manual. The styler looks after that for you. But if you want to dig in, you can find out what these things mean by looking in our reader and writer manual for AutoCAD. And that's set it all up for us. Secondly, I'm going to style my lines. And again, here, what's happened is I've gone to a database joiner, and it has added a bunch of line types and colors so that when we go to AutoCAD, we get what we want. And now I'm just going to take a peek to the final result. And so here it is. And I have available to me both blocks. So these little symbols here are the blocks, they're sort of little stars along the street, as well as the lines. And if I zoom way out here, you can see kind of all this funny styling and so on having been applied to our data in the city of Gävle. So there goes all the point features, all those blocks, all the many, many pieces. And with any luck, in a second here, we should see the lines. Come on, lines. I know you're there. I'm counting on you, lines. Wow, there's a lot of blocks drawing slowly. There they come. Here come all their lines in a rather gauche coloring scheme that we've invented. All right. So that's the solution there. And this is the kind of output that we get. Again, for applying styling, we're going to store the styling information in a spreadsheet as much as we can and apply it during translation. We get the definitions from a template CAD file that the engineering team has provided, and then we just use those. Database joiner is a great way to get that styling information, but if you just have a few things to do, you can always use the DWG styler that sets up the appropriate attributes as well.
All right, on to our next scenario for self-serve data requests. But first, a customer story from the city of Burnaby. The city of Burnaby needs to provide a call before you dig service to ensure the protection of underground utilities from excavation in a timely manner. Due to an exponential increase in new development throughout the city, the volume of applications to dig increased by more than 6,000% within the past 2 decades and continue to grow. The city implemented FME to power an automated service to meet this demand. Applicants now receive their underground information package within 3 minutes without staff intervention. So similar to the City of Burnaby's automated one-call system, we're going to create an FME server app that delivers Surrey Trails data for a user's selected area of interest and provide a download for that data in CAD format. So from here, we're going to head into FME server apps. I've actually already got it open from that URL. So I have my Surrey Trails data, and I can go into here to select the area of interest. I've just got Surrey Trails data, so I want to be focused in Surrey. And I have a box for kind of a default area already, but I can remove that and draw a new polygon. Let's grab that. I'll hit confirm and press OK. So what I'm expecting now is that a workspace is running in the background to clip that polygon I just created to the data set and return me a CAD file to download, which is this data download URL here. Going to go ahead and download that, and I get a zip file, and we're going to head into the FME data inspector to take a look at that information. I'm a very big fan of drag and drop, so I will go into my downloads, grab that zip file from just now, drag and drop it in here. I know it's a DWG file, so I'm going to put in the format. It's totally fine that it's a zip file. And one important key piece is that I want to change my group entities by to attribute schema so I can see that table information that I've kept from my GIS. Turn my background map on. And there we have it. This is about the area that I selected. If I zoom in a little bit into green timbers, just because there's a bit of a higher contrast in the color here, you can see vehicle access. We've got information on the description, as well as the type of material you're walking on, so gravel or limestone or asphalt. And we were able to get the data that we wanted. So let's take a look at what powers this workspace. So now that we're in Workbench, we're looking at our data download service, and this is the workspace that takes that information, clips it, and gives us back our DWG. So in our first bookmark here, we are taking that bounding box as a parameter, and then we're reading in our data set of trails data. Next, we're clipping it, and the reprojectors and coordinate system setters are to make sure that that information really does overlay in the real world in order to clip it. And finally, we're managing some attributes and writing out to our CAD file. Something important that I'd like to show here is to do with the coordinate system. And under Advanced, there is an option for the coordinate system storage. So as you notice from that zip file, when I pulled it up in the data inspector, I didn't have to say where it was. It just automatically knew and showed on the background map. And that's because I had written out the internal WKT, or well-known text. Some other options you can mix and match with are to write an external companion file, or a PRJ projection file. And that will be recognized by different GIS programs. Internal native is one that you might want to use if you're bringing it directly into AutoCAD and you want it to know immediately where it is without having to specify. So internal native is a good one for that. And you can just find it in the parameters, the writer parameters under advanced, and that's the coordinate system storage. So this is the workspace that runs it. With that, I'll head back into the slides. So this is just a screenshot of that same workspace. I've attached a link there that when you access the slides, you can get to the tutorial that creates this kind of workspace using the geometry picker and FME server if you wanted to do something similar. And this is a screenshot of the template DWG I used. So while I was in the workspace, I should have shown this as well, but in the writer, I've used the template DWG. You might have noticed that I didn't have any DWG stylers or kind of styling transformers, and that's because of this template. I've already set my layer names, my colors, my layer colors, and line types and line weights here, so I didn't have to do that in the workspace. So to recap the scenario, our task was to create a data download service or portal for self-serve data. Anyone I've given permission to use the app can select an area of interest in Surrey and download Trails data as a DWG CAD file. Not only does this ultimately reduce wait time for someone needing the data, but it also provides data from a source of truth, where the data is up to date and no one needs to worry about old versions of data sets being passed around for years. Some of the transformers highlighted from this workflow are transformers that style CAD and create symbology. But one of the key concepts in this workspace is really the use of a template DWG to set up my layer symbology. Another point of interest is the georeferencing. As you saw my trails aligned correctly with the background map, I had retained my coordinate system information from the GIS by writing out with the internal WKT selection in the writer. The other options were to use the external PRJ or internal native. So some of the transformers highlighted here are the DWG and DGN stylers. So it's not just AutoCAD, we also support MicroStation files. And some other kinds of tools that are useful are the labeler or label point replacer and the map text labeler. With that, I will hand this back to Dale then.
Well, thanks very much, Jovita. And thanks everyone for tuning in today to hear us talk about achieving harmony between CAD and GIS by automating integration. We advertised it as 8 simple ways. We actually had 7 plus 2, well, 7.5, because we did 2 kinds of schema drift. So I'm going to call that 8, but we hope you enjoyed all the different examples that we showed. Of course, everything we showed, the workspaces are available for you to download off of our archive webinar site, and you can explore them yourselves. If you want to dig in more deeply, you can always go into the tutorials that are in the FME community, whether it's going from GIS to CAD or the other direction. That's all a bunch of great material there that you can explore and look at when you have a chance.
Awesome, thanks Dale. And with that, before we dive into some Q&A here, I will share my screen and share the community badge code that you can redeem as a thank you for joining us today. And as Dale mentioned earlier, if you have yet to join our community, definitely check it out. It's the best place to ask questions, find solutions, and network with others. So the code today is BMFSL, and I will drop that in the chat shortly here as well. And with that, it does look like we have about 7 minutes here for some Q&A and lots of great questions here this morning. So I'll invite our presenters back on stage. Any that we might want to start with here, Dale and Jovita?
Let me get back to that tab. Well, first of all, thanks everyone for tuning in, for the kind remarks on the right-hand side and the good questions. It was a good set of questions there to keep Jovita and I on our toes during the thing, during the broadcast. But Jovita, did any question particularly jump out at you?
There were so many good ones. It's actually really hard to pick. I was almost going to suggest starting from the bottom up.
Okay. Okay, so the bottommost one, at least on my screen, is the one about how much do we see each of MicroStation and Autodesk or AutoCAD used? And the answer is we see a lot of both. I did mention in the answers there that according to our usage stats, there's more AutoCAD out there now than DGN, but still DGN is in the top 10 of the 450 formats that we do. So now DGN also, sorry, DWG, there's a few different flavors. Of course, Civil 3D. We didn't touch on Civil 3D in this webinar, but FME does an excellent job of reading Civil 3D if you have that sort of thing in your environment, as well as Map 3D, the object data, we do that as well. So people have used us for that. On the DGN side, we do version 7 and version 8. and both read and write that. And in the past, at least where we come from in British Columbia 30 years ago, MicroStation was the show in town for making maps. In modern times, that is not as much used in that way. But in certain pockets of our user base, we see a lot of MicroStation used for sure. Looks like, Jovita, people were asking about expanding cells and getting the insert point. We should, I noticed you gave good answers there. Definitely, we should have options in the reader that should let you get what you want. But I think, Jovita, you were saying that there's some that basically flip those off and on in the reader parameters.
Yep, by default, it does expand cells. So if you do not want them expanded, so you don't want them coming in as points, you want to turn that off and set it to no so that you get the insert point instead. I saw a good follow-up question from somebody else about nested cells. I don't know if you call them nested cells. We call them nested blocks. So some of my language might be a little bit like crossed there. But if you do have cells within cells, I'd expect the expand named cells or expanding cells to be able to dispose them into their points. So into their insert points. And if that's not happening, then please do let us know. But would you agree there, Dale?
Yeah, I think it's been a while since I've looked at that, but I kind of think there's a set of options that you need to explode or expand the cells / blocks. And then you're going to get, like the smiley face and other things that are going to be in there, but you could throw that information away and just pick out the insert points. So it'll be a little bit of work with that feature information window and understanding what you're getting. But between looking at the options related to cell expansion and then filtering things out with a tester, you should be able to get what you want. Certainly FME was designed to do what is desired here.
Our CAD readers definitely have a lot of options, but don't worry too much. They're all documented, so you can check through the help and read what each parameter does, and then try them out be able to configure them as you want it. So
yeah, I mean, we've been doing this for nearly 30 years, which yikes, I'm getting old. But over that time, we've really encountered almost every kind of situation. And so our policy has always been to try to give you as much power as possible. That means there's a lot of options to wade through, unfortunately, but that does also mean that if you find your way in there, you should be able to get out exactly what you need.
Seeing some questions about any future for Bentley AEC, open roads, and open building. I believe there's some exploration going into, I think it was open roads.
Yes.
I can't remember exactly the Bentley program, but we're definitely looking into some of that.
Yes, we have good relationships with really all the vendors, but Bentley, of course, as well. A long time relationship. Bentley and I started working back in '96, actually. Wow, the late 1900s, as I like to say. And so, yes, we definitely would want to look at what we could do and to make better support in those areas. So thanks for that. I see also someone asking about Revit and LiDAR. Elizabeth, I think we would have some webinars we did on, I'm going to kind of put Elizabeth on the spot to maybe chat out links to the Revit webinars that we've done in the last year. Actually, that I think would get you, we definitely can read Revit very well. And at our user conference 2 weeks ago, we showed or teased our upcoming Revit writing, which is more of a slim BIM right now, not exhaustive, but nonetheless a first step on the Revit writing side. And LiDAR, we've done some webinars on that over the years. I can't remember how recently, but definitely FME has some powerful LiDAR things in it as well.
Within the year, for sure. I know we have a LiDAR one. If you check our safe.com/webinars under the on-demand, just look up LiDAR and you'll be able to find it there. I think Elizabeth is working on grabbing those links for you, as well as on the BIM side. There's BIM Webinar 1 and 2, which are really great places to get started with reading Revit and working with that.
Were you part of those webinars, Jovita, the BIM ones?
I was part of the first one, yes.
That's what I thought. I just want to put you on the spot, and I should have done it. So, yeah. Let's see what else.
Perfect. Yeah, there's actually a few different webinars here. I'll drop in.
Okay, there's Elizabeth chatting out in the chat, not the questions area. Oh, there's some questions in the chat, I see. Let's see.
Yeah, a couple have been dropped in the chat there.
So James asks about IFC and GIS, and I can't remember. I think we've done a webinar on IFC. Certainly we have a lot of expertise at SAFE with that. I will be transparent. IFC writing is sort of master's level FME technology, but it can be done. And so you can use FME to take GIS stuff and go to IFC. And but that might be something you might almost want to follow up with us on, or if we can dig it out, there might be a webinar that we've done on IFC, but I can't remember when we did. Dave Campanis is our in-house expert for sure on that. Jovita, have you flirted with IFC in your career yet?
I have a little bit. The quick answer to GIS attributes to IFC is probably property sets. It doesn't keep attributes the same way that some of our writers do, where we just write our attributes out and it's user defined. So it does take a little bit more diving into, but Dave's examples really got me started. And there's one that goes from AutoCAD to IFC, which is kind of the main, kind of my bread and butter of how to work with IFC. And I definitely recommend that. When we head offline here in a sec, I can put that out in the chat for you.
Yes. Yeah, look at, if I type FME IFC, you get all kinds of good stuff coming up. There's a BIM tutorial. Okay. There's a BIM tutorial on the community that might be of use. I'll paste that in too.
Sounds good.
Except I can't. Elizabeth, I've been banned from posting to the.
No.
All right. Well, I've cut down. My wings have been clipped.
I'll find it. I think we missed a question from Sam above James's question about whether FME can be used to extract layers or features from PDF to CAD and GIS. It is definitely possible to read from PDF. It is tricky. We have a geospatial PDF reader, but it depends kind of what was contained in that PDF. To be able to bring that back into a GIS realm, PDF, I think, is certainly one of those formats where you want to use for viewing and sharing. So when you're grabbing geospatial data from a PDF, it's a little bit less fun, but definitely possible.
Yeah, and again, if you search for FME PDF on Google, a few resources do come up. But yeah, the challenge with PDF is that it's a pretty Wild West kind of format. And so as Jovita says, we never know what we're quite going to get. That said, well-behaved geospatial PDFs, we should be able to read them and get stuff out, which is pretty miraculous because, of course, in the industry, the line often that is said is that PDF is where data goes to die. But we can breathe life back into it. I think we should have done a webinar on that. PDF resurrection, sort of like alien resurrection. What do you think, Elizabeth?
That sounds great.
Okay. The masked Revit user. That was kind of a fun webinar. I forgot about that. I think, what was the movie that was sort of The Dude Abides? I know that was a line from that movie, or from that, well, the movie and the webinar. So if you want to see The Dude Abiding, we had a guest star with us on that webinar. So that's actually a very good one if you're interested in Revit. Let's see, anything else we should answer, or should we let these people get on with their day?
Just reading through the questions, I'm flipping between the tabs and realizing I'm missing things.
Yes.
It's a good problem to have. A lot of great questions today.
So many tabs and so little time. Yes, I'll follow up with Sam here. If a PDF was generated from GIS, yes, it is more likely, yes, because the GIS systems that make PDFs do that fairly well behaved. So yeah. So yeah, how does we handle PDFs? We have a reader for that, and you throw it in there, and there's a few different options about what you want to try to get out. But if there are spatial features and it's well structured, Deanna, you should get what you want.
There is an article somewhere about reading geospatial PDF, but if you take a look in the community, there are a couple of articles about working with PDFs in GIS.
Yeah, search for FME PDF and then spend a few minutes looking at the results, and there's lots. We do plan to swing around and do a better job of writing PDF more generally for reports and stuff. If that's of interest, do let us know for sure. And actually IFC, we kind of hinted that IFC is a bit hard to use right now. There is a plan as part of the new standard of IFC 5. There's a plan to reimagine our IFC reading and writing, and that'll be a longer project, but that's on the horizon. It's not 5 years away, but it's not 3 months away. It's somewhere in the middle, but that'll be a big deal.
Awesome. I think that about wraps us up. Any others we want to address, Dale and Jovita?
I just love that somebody asked a actually really insightful question about, this is a bit more detailed about FME, but is it better to use a database joiner or an attribute mapper? And the answer I gave was that the main advantage of a database joiner is it lets you put the intelligence of the translation out into an Excel file or a CSV or a database where mere mortals can make edits or changes to that. A domain expert can do it that doesn't know anything about FME. That's the advantage of having it outside. That information is maybe easier to reason with then. On the other hand, if you embed it inside FME, you have the advantage that you don't need an external file. The attribute mapper will do the trick for you. It's just infinitesimally faster. I don't think I'd make a strong speed argument, but it's just the convenience of having everything bundled in one place. So it boils down to, do you think somebody external is going to edit it? Then use the database joiner. Or if it's big and complicated and you want to use a tool like Excel to manage that lookup table, then database joiner is your friend. Otherwise, if it's small, manageable, and you want the convenience of everything in one place, go attribute mapper. As with many things in FME, there's several ways to, should we say it, skin the cat? That seems mean on this webinar, but anyway. Because I know we have lots of pet people, so I'm trying not to use that phrase, even though I'm a farm person. We never did, to be very clear, we never did skin cats on the farm. Never, never, never.
No cats were harmed in this webinar, in the making of this webinar.
No.
Let's see.
I think with that, probably Elizabeth's going to cut me off. I'll be banned from talking as well as posting.
Oh, boy.
Is there anyone else?
Yeah.
And anything we don't get to today, we will follow up. So if you had a question and it was not answered, we will I was going to say we'll find you. No, we will let you know.
We will track you down.
Yeah, and if you do think of any questions post-webinar as well, definitely don't hesitate to reach out, info@safe.com. All right, so with that, I will wrap us up today. If you have yet to download the latest version of FME, I just dropped some links in the chat for that. Contact us once again, info@safe.com, with any questions you have about data, and connect with us on the community. If you do have a moment to share your feedback on the webinar, we love to hear it, and it helps us continually improve the program. So there's a link for that as well. And with that, thank you so much for our whole audience joining us here today from all over the world. And thank you to Dale and Javita for presenting and helping with Q&A today. And hope everyone has a great rest of your day. Thanks, everyone. Bye for now.
Okay, goodbye, everybody.
Bye, everyone.